Hello, George Blake again, W6BDD, and this is number 3 on the ATU-1000. I know you've been probably eagerly anticipating this video, so I'm going to get right into it. So we're going to talk about some of the final connections you need to make and a way to keep the RF signals inside properly, and also how to tune your ATU-1000. You adjust it. So this is the box that I bought. It's available from Amazon or eBay, although I suggest you buy it from Amazon. It's cheaper. They run about $34 to $40. eBay, somebody wants like $56, $58. But it's basically 300 millimeters long and about 170 millimeters wide and 87 millimeters high, or roughly 11 and a half, 12 inches long. So you can see I mounted the power jack on the side. And right now I have it disconnected because I'm still doing some testing, and I'm also still waiting for my front panel. So as you can see, I've got all the switches hanging off the front as well as the display, and it's all working. The relay for before the coils and after the coils is activated. I want to talk to you a second about these connectors. These are not, I'm finding these are not the best RF connectors in the world. I'm not sure what the insert material is, but it's probably just plastic. I'm not sure. After heating it up and soldering connections, I find that the center pin for my cables don't quite make enough contact, so I had to go in and bend the inside in a little bit. It's split into 4 quarters, and you can bend them in slightly, but I wouldn't trust it for any period of time. At some point I will replace these. The circuit board for the center conductor is not quite big enough. The hole for the large copper, you can see I have it in there, and I'll explain that. So I don't want you, it's best not to use the smaller wire that they use for winding the small cores here. Use the bigger wire by all means. If you're going to push 1,000 watts or more, you don't want to find out suddenly that your center conductor has become a fuse. So what I did was I took my Dremel tool, and I used my carbide disc. You can use a disc, or you can use the sanding drums, or whatever method you have to take the annealing off. But I ground the wire down a little bit on the very end, so it was small enough to go into the holes in the circuit board. And then I soldered them in. Of course, solder tin the wire first, and then soldered them in, and build up the solder a little bit, and that will be fine. There's plenty of area there to take up the energy from that wire. But by all means, use the larger copper wire. Don't use the smaller one. Okay? So you can see how I've mounted both of mine. Another word about the mounting box. You can see that I've sanded away, ground away the corners, the edges around the connectors. And I also did, I'll show you here on the end of the box, I also sanded it. And for RF shielding, you want really good grounds. Okay? You can see I've got the wires into the crimp lugs going to the connectors, and around the connectors is all sanded away, ground away around the edge. so that when you put the box together, it has all electrical contact. This black anodizing that you see on this box, it's not paint. It is anodized. It's not that great for conductivity. That's why I sanded everything down. Paint is worse. If you buy a metal box or put this in a plastic box, that's even worse than having a painted surface. You want to get this thing shielded. So metal to metal contact all the way around. I made a few mistakes here and there. You can touch it up. You don't have to paint it to touch it up. Here's what I used. I used a Sharpie. Permanent ink. Okay? So any place you have scratches, you want to touch up the edges or anything like that, just use permanent marker. It works fine. Takes away all the blemishes, makes it all look nice and neat when you're done. All right, we're going to talk about tuning, adjusting your ATU. Let's take a look at our display here. You can see it. I'm not sure you can see it or not in this light. There we go. So right now you see it says 0, SWR 0. In order to get this adjusted correctly, so there's two pots. There's a forward pot, forward power pot, and a reflected power pot. So forward, reflected. Okay? And you turn them to increase value, you go counterclockwise, not clockwise. All right. So what you want to do is don't use those meters. Don't use that meter because those are for reference. Those are not calibrated. They work, they're nice, but in reality, they're not very linear, they're not very accurate. This is what you want to use. Something like this. This is a Bird watt meter. So you want a true power watt meter. Okay? You can see this model, I believe, is a 44, maybe it's a 4410. What does it say there? 4410A. This has a 1,000 watt slug in it. If you're going to go over 1,000 watts, the next stage, I believe, is 5 or 10,000 watts. All right, that's a 1,000 watt slug. I can adjust the power levels. Has a battery in it. Check the battery. Battery's still good. So this, what we call a slug, it's the element, it's the detector, has a multiplication factor. Okay? And if you can see there, I believe it says in red that it's times 10. So you multiply times 10 whatever your knob says. So if I want 1 kilowatt, there's 100 times 10, that's 1,000 watts. So full scale on top is 0 to 1,000. And then you go down from there. It alternates between 1 and 3 factor. So right now that's 300 watts. So you would read power on the lower scale, 1, 2, 3. 3 being 300 watts. That's full scale. So if you step again, then it's 10 times 10, which is 100. So full scale would be 100 watts, and so forth. So this is good because what we're going to do is we're going to measure both forward and reflected power. So I have my Yaesu. It's powered. It's going through the tuner, antenna tuner, manual antenna tuner. This is in bypass right now. I have this out of the circuit. So it's in bypass. So it goes straight through. This has no effect at all. Comes out, goes into the tuner, comes out of the tuner, into the bird watt meter, out of the bird watt meter, and into my loads. And you see there's a T connector there. I'll explain that. So the power is going to go through the power meter and it's going to go into the load. Now these are only rated for an instantaneous power of 300 watts. Average power is about 25 watts after several minutes. So these will get pretty hot pretty quickly. But hopefully we don't take that long to tune these up. I've already adjusted this pretty much already, but I'm going through this so you understand what's going on here. You see I've got a T, so I'm going to use both of the loads. Okay? Right now I'm just going to use one load for demonstration purposes. Why am I going to use two loads? Well, I'm going to have two loads in parallel. That gives me 25 ohms. These are 50 ohm loads. 2 in series is 25. At 25 ohms, the power is going to be divided, but I'm also going to get a high reflection. I'm going to get almost 2-to-1 VSWR. So it's about, I measured about 1.87. So it's close to 2. You're going to need that because with only one load, 150 ohm load, you're going to read an extremely low reverse power. So how do I get forward and reverse power? Well, you see that this element has an arrow. So the arrow indicates the flow of power for it to read energy. So I've got the power coming in here through the element and out to the dummy load. So this is the forward reading direction. Now what I can do is I can turn this 180 degrees, and now I can read the reflected power. If I had the connection swapped on the watt meter, then this would be the forward direction, and then this would be the reverse direction. So we're going to read this in the forward direction. First, we're going to start with one load. Now, normally you don't leave a T section open. This is a purely resistive load. There's no inductance. You don't want to use a wire wound resistor. Okay? Get a real dummy load. There are 1,000-watt resistors available from like DigiKey, Mauser, and so forth. They're from Ohmite. They're very flat pack. They're resistive, non-inductive. They run about $101, $120, something like that. If you put one of those in a small enclosure with a fan, I guarantee you will have a load for a true 1,000 watts. These are 25 watt loads. They will initially handle up to 300 watts, but soon after that they get very hot. As resistors get hot, they change value. You will see your meter readings change, go down, and it'll screw up your ability to do any long-term adjustment. All right. So what we're going to do is we're going to power this up. First thing we're going to do is we're going to do a check just to make sure everything's working okay. So I'm going to key up in CW. So I have power. I have power on these two meters. You can see I have almost no SWR return. So now we're going to adjust this. I'm going to go to, let's see. I'm on 300 scale. There's 100 scale. So my Yaesu doesn't put out more than 100 watts CW. Obviously more than that in sideband. So there we're going to key up, and we're going to see about, it's about 88 watts. Yeah, it's about 88 watts. Okay. Key it up again. Just to make sure, 88. Okay, remember that number. So I got 88 watts forward. We're going to turn the slug around. I'm going to drop this about 3 scales. So maybe lower than that. So that's 0.1 times 10. So the maximum is 1 watt full scale. So now we're going to see. So that's about a tenth of a watt. 0.1 watts return. Okay. Just to make sure. Now see, it's already starting to drop. Heaters, resistors getting hot. Okay. We'll call it 0.1. So you've got 88 watts forward and 0.1 watt reflected. Now, when you hear somebody say, oh, I've got a perfect match, I got 1.0 to 1, nobody ever has a perfect match. They probably don't have a sensitive enough meter to read that low, but nobody ever hits 1 to 1, 1.0 to 1. Okay, and I'll show you why in a second. All right. Here's where your wonderful high order math comes in. You math majors. So I'm going to give you the magic formula here. I know there's all sorts of charts and graphs and things that you can look at. But if you want to do the true calculation for VSWR or SWR, this is the formula. So it is, I'll put V parentheses SWR. Some places say it's SWR. Some places tell you it's VSWR. So we'll just use V in parentheses. All right. That equals. You ready for this? All right. Draw a line. It's a division. So you have 1 plus square root of power reflected over power forward. So remember, we took both readings. We saw the reflected power and the forward power. So that's the numerator. The denominator is 1 minus the same ratio. P reflected, P forward. Okay, and that will give you your magic number that you want to shoot for. All right. So the forward power, I've already adjusted. Let's see if I can get it to zoom in here. Come on, there we go. So you see there, I've got about 88 watts. Okay. So that's the first pot. That's the one that's for the forward power. That's the pot on the right. That adjusts your peak power. Okay. And you may have to play with it. I'm sure once they get up to 1 kW, I'm going to get about 600 watts with my linear here, my Gonset. I get about 600 watts CW and a little over 1 kilowatt on sideband. Okay. So you're going to adjust that pot first. Pot on the right. Okay. So you're gonna key up. While you're keyed up, now don't tune this thing. That'll throw everything off. You want it just like it is when you power it up for the first time, or if it's not like this, press your tune button down, hold it till you get reset. All the relays relax, and you only get K2 to be lit. All right. So that's the bypass mode. We talked about this last video. Okay? So you don't want any capacitance or any inductance in that line when you adjust these. All right. So what we're going to do is we're going to take this ratio, and what did I say? About 88. So P forward equals 88. P reflected turn the slug around here. We're on 0.1 scale. Times 10 is 1. So I get about what? About 1.2. 1.2. 1.1, 1.2. 1.1. Turn the slug around again. Change the scale up. Ten times 10 is 100. We're going to hit this. Now it's going to go up to about 88 again. So let's try this again. You say 1.1 divided by 88 equals square root equals. So I get 0.1118. Stow 1. Okay. .1 divided by 88 square root. Oops, that's an error. 1.1 divide 88. Okay, square root. That's right. Stow 1. Clear. Parenthesis 1 plus recall 1. That's right. Divided by 1 minus recall 1. Divide equals. You see again it changed a little bit. Now first time we had about 1.28, I think. 1.25, so you're right around 1.25. All right. But when you hit this, you see it retreating a little bit high, or a little bit low, I should say. So it's not quite enough power. And you see the SWR is changing a little bit. Okay. So we've got the high end pretty well set. So now we're going to set the low end. So how are we going to do that? Sorry I'm wasting your time here a little bit. All right. So what we're going to do is we're going to connect the second dummy load. So now we have 25 ohms instead of 50 ohms. So what is this going to do? This is going to cause more power to be divided. It's also going to cause a higher reflection. So this, in theory, should be a 2-to-1 reflection. Now, I came out with a little lower number than that, 1.87. So let's give it a shot and see what we get here. So I'm going to go to what? 10 times 10 is 100. Okay. We're in the forward position, so we should reach forward power. I've got 2 loads in parallel. This one's getting a little warm because all the power was going to this guy. So now we have power going to both guys, but we only have 25 watts. So we're going to actually be outputting slightly more power, but it's going into two loads. All right. So if I take half of my power reading, and if I take my power reading and I double it, that's the actual power that's going out. Okay. So we're going to check this now. We're going to go transmit. So now we are at about 55 watts. Okay. My meter over here says, yeah, it's about 57. Now it's not going to drop down quite as fast because I'm equally splitting the power into two dummy loads. So it takes both of them time to heat up. Okay. So I'm at, yeah, about 54, 55 watts. All right. Now I'm going to take the slug and I'm going to turn it around. And we're going to drop it a couple of points here. So 0.1 times 10, 0.1 times 10 is 1. So now we're going to see what our return is. Bang, you can see it went way up. So now you can see a higher return in the reflected position. What am I doing wrong here? That's 0.3, there's 1, that's 10. So there we go. So I got about 4.6. I got 4.6 watts in the reflected direction. Okay. So now I'm going to take that, I'm going to write it down as my top number, 4.6. Okay. Turn the slug around again. Turn the knob up. Okay, we're not quite there. There's 100. All right. 100 watts. And there is 50. Around 52. We'll call it 52. That's down my bottom number, 52. So now I take the ratio. And what am I going to get here? Well, let's see. Okay, clear that. I'm going to take 4.6 divided by 52. And I'm going to take the square root. 0.29. I'm going to store that in 2. I'm going to take 1 plus recall 2. Oops. 1 plus recall 2 divided by 1 minus recall 2 okay, that looks good. Equal, and there I have 1.84, or about 1.85. So now I have a lot better number to adjust to, and I could take the number again and try it again. But in any point, that's the number you want to shoot for. So you would key down the transmitter with this on. And as you can see, I've already got mine pretty well set. It says 1.81. It's actually more like 1.84, but it's going to change a little bit over time and with power levels. So what you want to do is you want to try to do this maybe a slightly higher power, maybe 300 watts, and get it closer. But that's in essence what you're looking for. So now, as you can see, it's saying the power out or power in to the unit is 53 watts, out to the antenna is 30, and the efficiency is about, what does it say there? About 59%. So now I'm going to key this up, make sure that's back in the forward direction. We're going to take the meter out of the circuit. And now what I'm going to do is I'm going to tune it at that power level. Because I've got a higher VSWR, we're going to see how well this thing actually tunes. So I'm going to turn on my transmit. Oops, sorry. So there's my transmit on. I'm going to grab the tune button here, and we're going to say tune. And there we are. It just changed the impedance characteristic. I've got what? I've got some capacitance. Do I have any inductance? Nope. And the reason for that is because you are looking at a dummy load. You can see this relay K2 went out. So it's now after the inductors. And you've only got one capacitor in there. And so that is because you're looking into a purely resistive load. I'm going to turn the power off, let those guys cool off. Okay, so keyed it up, hit tune, it tuned in, and there you go. So that's how you adjust the power on this thing. So you take and you key it on, turn it on, transmit's on. Actually, we want to clear it first. Here we go. Let's get this thing to reset now. Okay. There we go. So there's in reset. There's no inductance, no capacitance, no power. Hit this on. 1.84, efficiency 59%. If I turn this on, so I'm going to play with this a little bit. See what happens. Oh, let's go up here so we see what we're doing. Okay, so I'm going to start at 1.84. What did I say, 1.86? There's 1.86. You cannot adjust this for reflected power. You have to get your VSWR, and then you need to adjust the second pot, and that will show a difference in the SWR. You're adjusting the reflected power level, but the IC, the PIC, is converting it into what you see on the display. All right? So that is pretty much how you tune this thing. I'm sure you'll work with it a little more than I did, but that in essence is how you get this thing to work and how it finally works in the tuning. All right? So my last video, number 4, coming up, will be with my front panel mounted and the whole unit boxed up. And maybe I'll do number 5 at some point as soon as I get my vertical up and my fan dipole. But that in essence is how it works. Right now it's working good. Like I said, I am going to change out these connectors, but aside from that, that's it for now. So 73s, and good luck with your project.